So we are skipping the do now, going straight into the lesson. Okay, and we are going to learn a new theorem that we are using in proofs. I will tell you, this theorem is called the no choice theorem. It does not, capital N, capital T, does not prove triangles congruent. This is not a way to prove triangles congruent. What does the no choice theorem tell us? It tells us if two angles of one triangle are congruent to two angles of a second triangle, then the third pair of angles have to be congruent. This makes perfect sense. Let's say I told you angle A was 60 and angle B was 40. And then I told you in the given information, angle A is congruent to angle D. Well, if angle A is congruent to angle D, what does that mean for angle D? It has to be 60 degrees. And then I also told you that angle B was congruent to angle E. Well, if angle B is 40 degrees, what does that mean for angle E? It is also 40 degrees. Right. What is the measure of angle C and Y? What's the measure of angle C and Y? Good. How did you know it was 80 when I didn't tell you that it was 80? You got it, because remember, the sum of the interior angles of a triangle has to add up to 180. So if two of the angles, one is 60, one is 40, wouldn't the last angle have to add that up to 180? So the last angle would have to be 80. Same thing here. If angle D is 60 and angle E is 40, wouldn't angle F have to be 80 degrees? Right, so it makes perfect sense. If two angles of one triangle are congruent to two corresponding angles of another triangle, wouldn't the last pair of angles have no choice but to also be congruent, since all triangles have to add up to 180, the sum of their interior angles? Right, that is the no choice theorem. There's no choice but for the last pair of angles to also be congruent. Does the no choice prove triangles congruent? No, no choice does not prove triangles congruent. No choice proves the last pair of angles congruent, not triangles. All right. So, remember when we were going through ways of proving triangles congruent? We had said, well, side, 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 angle, angle. And then what did I say about angle, angle, side? We said not yet, right? Didn't we say not yet? What did that imply when I had said not yet?
It's possible, but we don't know how it works yet.
Good. We're going to use it, just not yet. Well, guess what? Today is yet. All right, today we are using it. We're going to learn why this makes sense. I'm just going to explain to you. You do not have to write this down. So let's say I have two triangles. I have triangle ABC and I have triangle DEF. And in the triangle, I have angle A congruent to angle D, and I have angle C congruent to angle F, and I tell you that BC is congruent to EF. What do these tick marks suggest? Angle, angle, side, right? And as of this point, it really wasn't a way to prove triangles congruent that we were using just yet. But look at what we have. Don't I have 2 out of the 3 angles congruent?
Yeah.
Okay, so by the no choice theorem, what does the no choice theorem tell us? If you have 2 out of the 3 angles congruent, what does that say about the last pair of angles? They also have to be? So in this scenario, wouldn't we always be able to get the last pair of angles congruent?
Yeah.
And then if we get the last pair of angles congruent, wouldn't that be angle, side, angle? So anytime we had angle, angle, side, because of the no choice theorem, the last pair of angles would be congruent, which would make it angle, side, angle. And isn't angle, side, angle always a way to prove triangles congruent?
Yes.
So the mathematicians went out to coffee and they're like, okay, well, let's take a vote. If we're always able to make it an angle side angle. Shouldn't we be able to just accept angle angle side as a way of proving triangles congruent? They took a vote, it was unanimous, and then angle angle side became a way to prove triangles congruent. I know because I was there and I voted. Do y'all believe me? Yeah. Okay, nice. All right, so we're not going to do no choice theorem. Okay, let's show you how angle angle side works. You do not have to make it angle side angle. Just cross off this side. We're not going to use the no choice here. I'll show you in different scenarios where no choice would come into play. All right, so if I have angle G congruent to angle K, and I have angle H congruent to angle M, and we have JH congruent to OM. So I go through, I mark my given. All right, I look at those tick marks, and as of right now, we are now allowed to use angle angle side. So then we would say triangle GHJ is congruent to triangle KMO AAS, angle angle side. It is now a way to prove triangles congruent. So now you might be saying, okay, well, we understand when we can use angle angle side that it's now a way to prove triangles congruent. Then what is the point of the no choice theorem? Well, let's see the point of the no choice theorem. Does no choice theorem prove triangles congruent? No, no choice theorem does not prove triangles congruent. So when will it ever help us out? Let's see. Let's go through our given information. Oh, sure. We ready? Okay. So in the given information, I have angle A congruent to angle D. Now we want to prove angle E congruent to angle C. As of right now, there's absolutely no reason we are allowed to prove angle E and angle C congruent. So then in my mind, I'm saying, okay, well, when I can't prove what I want right away, what should I do? Prove triangles congruent. So in my mind, that's the course of action I'm taking. Let's try to prove triangles congruent. So we have angle A and angle D. Does anybody see anything else we can say? Oscar.
The vertical angles.
Excellent. I'm going to call them angle 1 and angle 2. So I'm going to say angle 1 is congruent to angle 2, and our reason is vertical angles are congruent. But then I'm sort of at a standstill here, because in order to prove triangles congruent, don't we always need a side? There's no way to get a side here congruent. Did it say anything, any segments were bisected or any midpoints? Did it have any of that? No. So there is no way to prove these triangles congruent. But I don't really need to prove triangles congruent because it asked me to prove angle E and angle C congruent. And aren't the two angles in this triangle congruent to the two corresponding angles in the next triangle? So what does that mean about the third pair of angles? They have to be congruent. Which theorem is that? No choice. So I'm going to say angle E is congruent to angle C, no choice theorem. Okay, so once again, no choice does not prove triangles congruent, but it does become helpful. Are we ready for the next one? All right. Let's do this proof. Okay, so we have circle O. I know it's been a while, but anytime I give you circle in the given information, what do I want written in the proof somewhere? Michael. Radii of a circle are congruent, so keep that in your head. Then we have angle SOV, follow your letters, so that's this big angle over here, is congruent to angle TOW, this angle over here. And we have angle 1 is congruent to angle 2. Right, we want to prove that SO is congruent to OT. Can I say right now that SO is congruent to OT because all radii are congruent?
No.
No, we can't, because even though it's starting at the center, why is it not a radius? Are there no tissues? No, it would only be in that one. It's probably on the lower shelf. Right there. Got it? Okay, sorry. Even though SO and TO, they start at the center, how come they're not radii? Julia? Good, it doesn't touch the rim of the circle. That's why they're not radii. So are we able to prove what we want? No. So what are we going to do? Prove triangles congruent. Do we all agree these are the two triangles we're going to try to get? Yeah. Okay, so we have angle 1 and angle 2. This red angle and this blue angle, they're too big. They're coming outside the triangle. Does anybody know how we can make, let's call this 3 and 4? How we can get just 3 and 4 congruent? Maya? You got it. We could do the angle in the middle reflexive and then use subtraction. So statement 2, I'm going to say angle 5 is congruent to angle 5 reflexive. Then I'm going to go ahead and say angle 3 is congruent to angle 4 subtraction. Okay, great. So now we have two angles. Remember what we said, we need to use the circle. Does anybody see sides of these triangles that are also radii? Does anybody see full sides of this triangle that are also radii? Simon?
WO and VO.
You got it, WO and VO. So then I can say WO is congruent to VO. Radii of a circle are congruent. So now I can go ahead and say triangle SWO is congruent to triangle TVO. And what's the reason? Look at your markings. Nobody? Mia? You got it. Angle, angle, side. And now that the triangles are congruent, now I can say that SO is congruent to TO, CP, CTC. All right, let's do another one. Actually, we don't even need to do this one. That's it. We don't need to do the independent either. We're done. Let's call it a day. All right, guys. All done.